Forgive me. I'm trying to resolve a slight technical issue. Okay. Today's program, Reducing Embodied Carbon, Opportunities and Risks for Design Professionals, is intended to give you a preview of the changes coming to professional practice as the world transitions to an economy that relies less on the consumption of fossil fuels that contribute to climate change. Climate change has been identified as the single greatest challenge of our time. It is now settled that emissions of major greenhouse gases resulting from human activities build up in the atmosphere and warm the climate, leading to many different changes around the world. Many of the major greenhouse gases stay in the atmosphere for tens to hundreds of years after being released, and their warming effects on the climate persist over a long time and therefore affect both present and future generations. And as you know, we have done programs in the past addressing design liability in a changing climate, where we have looked at challenges due to higher temperatures, increased flooding, and so on due to climate change. In this program, we will look specifically at changes to the built environment that we expect will be more commonplace as the world addresses carbon emissions. So let's establish the big picture first. The Paris Agreement of 2015 and COP26 Climate Summit established a global consensus that climate change is caused by greenhouse gases and that the world needs to take steps to drastically reduce gases that are contributing to climate change. It's recognized that the climate has now been irreversibly changed, with sea levels continuing to rise, and that indeed our global climate system is considered unstable. And as we've discussed in the past, there's a lot more severe weather events related to this climate change. At least that's what scientists are saying. So to stabilize our system, the global economy must pivot with strong, sustained emissions reduction efforts quickly. And while it wasn't clear until recently that the United States would be part of this global effort, with the Biden administration recommitting to the Paris Agreement of 2015, that has a goal to reach net zero emissions economy-wide, and trying to limit temperature rise from pre-industrial levels to 1.5 degrees Celsius, it seems that the US indeed is now part of this global effort, especially with the passage of the Inflation Reduction Act that passed earlier this year. And as we should see in the presentation later, the Inflation Reduction Act has specific programs designed to address embodied carbon reduction that you as design professionals should at least be aware of. But in addition to governments acting to reduce carbon emissions, we have organizations across all industries, private companies, that have declared greenhouse gas emission reduction targets, including for some what's called a net zero commitment, in which a company says that they will ensure that emissions from their value chain activities create no net climate impact. In 2020, for example, more than 4,500 companies worldwide self-reported their greenhouse gas emissions for public disclosure, and about 40% of those companies have committed to specific emissions targets as part of their strategic and financial plans. What this means is that, as we've talked about in our programs with their ESG commitments, that the effort to remove carbon from their activities, carbon emissions, is going to take on added importance and will play a bigger role in the economy going forward. So let's look exactly at how the built environment contributes to climate change. Overall, studies show that the built environment generates almost 50% of annual global CO2 emissions, and that's what we're looking at in this chart. The building operations are responsible right now for around 28% of that. And what we're talking about today is the embodied carbon part, and we'll define that a little more detail later. But that's responsible for an additional 21% or so of the total emissions. So as you can see, if these commitments to reduce carbon emissions by countries and companies are to be met, the built environment and how we build will have to change. Moreover, it is expected that by 2060, the world is projected to add about 2.5 trillion with a T square feet of buildings. So that means that unless we are serious about reducing the amount of carbon in the building materials themselves, we're not going to get anywhere close to any of those commitments that companies and governments have made. And as we've said before, your facilities generate greenhouse gas emissions, but this is actually a piece of the puzzle that is continually improving. The solutions that are expected of you all due to energy efficiency requirements, electrification of new facilities, improvements to the power grid, which means cleaner energy, means that the portion of the greenhouse gas emissions that arise from operations over time will be decreasing. And what we will see is that the embodied carbon in building materials will play a bigger part from that 21% we talked about in that earlier chart. And if clients indeed are very serious about reducing the amount of embodied carbon, one potential impact could be that renovating and retrofitting facilities will become more attractive as opposed to building a brand new facility, because that would mean that you are not releasing carbon into the environment when you demolish your facilities. So that could well be a change in the nature of projects going forward. So what is embodied carbon? It consists of all of these greenhouse gas emissions associated with building construction. And it has nothing to do with the operation side to your facility, but where do the materials that we use come from, and how much carbon do they emit by the time they are put into use in your facility. So you will have to look at things like extraction, what technologies are being used to extract the raw materials, what are the sources of energy being used in the extraction process. Obviously, transportation, how far away is the material that you selected? How is it getting to your site? If your client is indeed interested in reducing that embodied carbon, then you may not be specifying finishing materials from China as opposed to locally sourced solutions, because the carbon impact would be significantly different. Manufacturing, this is another measure that will have to be examined if a client is serious about reducing the amount of embodied carbon. What does the manufacturing process look like? What is being done to reduce the amount of carbon that will be emitted in the production of this material? And then, of course, how much does it take to install these pieces on site? As we will talk about a little bit later, for example, modular construction technology, if that is indeed being adopted, is known to use less energy on site because these are already completed modules that have been produced off-site, have been transported to the site, and the installation efforts are much less when compared to solutions that are built on site. And then finally, operational and end-of-life emissions associated with the materials themselves. So what is the expected life cycle? And at the end of that life, what is the likely outcome of that material? If, for example, you're using wood, that is more likely to be recycled. and reused as opposed to some other material. So all of these things will be looked at if the client is indeed serious about reducing embodied carbon. And you as a design professional will be called on to provide an assessment of what the life cycle of these different materials impact will be on emissions. So let's look at some of the building technologies that are coming to the industry or are present challenges as far as greenhouse gas emissions and some of the major steps that can be taken to reduce those impacts. Concrete is recognized as the highest, one of the highest emitters of greenhouse gas emissions. It is carbon intensive because cement itself uses high processing heat to be produced. You make cement from limestone, and that accounts for a lot of carbon dioxide emissions, especially if your energy source is not responsibly sourced. Not only do you produce do you need high temperature to create cement, but also CO2 is also released during a chemical reaction during the manufacturing process, and that also adds a lot of CO2. Indeed, limestone, which is used, to make cement, is considered a fossil reserve, so it's really akin to extracting oil and gas and releasing that into the atmosphere if you're making cement. One thing that folks know about this, know about the challenges, and the way to reduce that is to move away from prescriptive specifications that focus on cement, water cement ratios when you're specifying the product. Instead, the recommendation, if indeed the owner is, again, interested in reducing the amount of carbon, is to use instead performance specifications, and you'll be focusing instead on the performance measures such as shrinkage, pumpability, or permeability, and what the real ultimate strength should be when the facility is put into use, as opposed to, say, using just its strength at 28 days, which may not reflect exactly what is needed from the facility. It's a lot easier, obviously, to just use prescriptive specifications because the industry is well geared towards that. But if we're to shift away from concrete or to reduce the amount of cement, we need to address the problem. And one way to do that is with performance specifications. Obviously, that's not as easy as it's not a simple fix. You would need to have buy-in from obviously the owner, but not also from the authority having jurisdiction over the project, because building codes come into play as to what they are willing to approve. The contractor themselves have to be comfortable with using performance-based specifications. And then finally, and most importantly, the local concrete supplier has to be able to indeed produce the concrete that is necessary. And from what I have seen, there's still a great amount of variability about the availability of these types of concrete, depending on where you are in the country. But I think change is coming, and more concrete suppliers will be able to adjust or make the changes that are necessary. Another culprit, obviously, is steel. Just doing research for this, one had to remember the material science courses one took, and it's amazing how much heat is required in a blast furnace to make steel. And every ton of steel that's produced emits about 1.85 tons of CO2, and it arises at different points in the steel production process. There's a number of furnaces involved in the production process that emit carbon dioxide, and obviously the heat source for that should also be examined if you're looking at the embodied carbon in your solution. It's an energy intensive process because you're trying to transform that iron ore into steel. So with that said, I think clients or steel solutions, there will be greater emphasis on the source of steel. Uh, Fortunately, steel can be recycled. So I think that will be the direction in which clients will be steered to try to use recycled steel um, instead of steel that has just been manufactured from iron ore. I think that's the direction in which you'll be going. There are some innovative technologies out there about using hydrogen and so on, but until those become commercially viable, you're still trying to reduce the amount of fresh iron ore that's converted to steel, at least currently. But as we'll talk about, there's a lot of change in the industry, and this could be something that could change very easily as more research and different methods of producing steel come into play. The other technology that I think will be more and more used is mass timber, cross-laminated timber. It's an engineered wood product where you're compressing and gluing layers of wood together. It's manufactured offsite, and the building components themselves are large wood panels or load-bearing structural columns that are secured in place using fasteners or adhesives. Uh, Mass timber is great. It can be built to similar strength ratings to concrete and steel while weighing significantly less. And the processing of timber into mass timber doesn't use as much carbon, energy that releases few emissions into the atmosphere. Um, Obviously, you're assuming that the wood itself is sourced from sustainable timber harvesting, so it'll be important to make sure that the source of the ultimate wood itself is meets requirements to be deemed sustainable. Um, and it's gaining in the United States as more and more, but there are still challenges in using mass timber. Uh, the challenge relates in some sense to how property insurers look at the product. If it's rated as similar to a wood framing building, then the insurance rates for owners to insure that property could be higher. But there are efforts underway to create its own classification, and owners may be more receptive to mass timber. And I think the insurance industry is looking to create solutions to treat mass timber differently than wood framed buildings. So it's gaining more and more in acceptance. We see projects here in the DC area that have mass timber, especially 3-4 story office buildings. And I think that will be more and more common in the next few years. The other area that we think will be more common will be modular construction solutions. Producing these modules offsite in a controlled assembly line environment and then assembling it efficiently on site lowers your indirect carbon emissions because you're not delivering a lot of different materials to the site, and presumably you don't have as much of a construction staff on site. And studies have shown that there is a significant reduction in embodied carbon with modular construction. So as owners take on these challenges, this could be a more common solution. Right now, the we see modular construction used in housing, but more and more as more production facilities come online, that could change into some office type buildings or schools, and it really depends whether there is a close enough facility that could serve your project, but that could certainly be one way to address it. So that was just a brief rundown of the technologies that I think will be affected and some of the things that will be adopted. But from a designer standpoint, how do you go about serving your client's needs if this is indeed a driving force for the client about reducing embodied carbon? Fortunately, there's a tool that's open source that is that collates all of this information that is available to designers. This is something that was developed by a consortium about 2 years ago. It's called the Embodied Carbon and Construction Calculator. It's available online, and you can compare what the alternatives are by using this tool. And you can use building material quantities from your BIM model, from your takeoffs, and use this database to compare options. Oftentimes, you have very detailed information, for example, about concrete mixes, about what the environmental product declaration is, and you are able to rely on that because the EPDs are indeed verified by third parties, and you as a designer are entitled to rely on this information. So there are tools out there. It just means that it adds to the services that you're providing that you could offer to the client. And the other development that you should be aware of, as I mentioned at the beginning, is that the Inflation Reduction Act actually mandates that the federal government spend money on low carbon materials. And the benefit to you all as designers is that the GSA, the federal government, is indeed one of the largest procurers of low carbon materials. And as their projects come online, you will have the benefit of being able to look at implementations of these solutions. So I expect that as the money starts flowing from this legislation and the projects become online, you will have access to greater amount of data, greater amount of information about what is feasible and what can be implemented or what has been implemented. As an example, there's $250 million for the EPA to support the development of standardized, high quality, transparent EPDs associated with construction materials. And we're already starting to see contractors being required to submit EPDs on the installations that they have so that a database can start to be compiled about what is being used out there. And so there's a lot of different programs, both through the EPA, through the Federal Highway Administration, and the General Services Administration. And more specifically, there's incentives in place to encourage the implementation of low carbon and net zero energy projects. And it's a whole lot of money in the billions of dollars going into these various programs. And all of this is going to mean that you will have the advantage, the ability to review these projects and have that information available to you in the next few years as more and more of these projects come online. So obviously there's a lot of opportunity there. It's an opportunity for you to amend your practice to respond to the market needs. But along with that comes some risks. And as from a practice management standpoint, it will mean that you will have additional costs and time. It'll take additional costs and time to verify embodied carbon in design solution. You want to make sure that these services are indeed, appropriately priced, and that you are not somehow caught in a situation where you're losing time because you've taken on a project that has a lot of these verification requirements. You want to be able to present meaningful choices to the owner on proposed solutions, including cost and schedule implications, because it's not always clear that the alternative may well cost more money. Impacts to the schedule will have to be accounted for. So to the best, when you do your research, you want to be able to advise the owner of what those implications are. And manage the client's expectations in regard to outcome. We are not going to transition to a net zero economy anytime soon. That's just not the way it works, and we will still be relying on fossil fuels, certainly for a few years yet. And it's important that the client's expectations about what can be achieved should be managed appropriately. And then finally, documenting installed products. Is this something that you're going to provide as an additional service, or is the owner going to rely on the contractor to verify that indeed what they're installing is indeed what was required in the documents? All of this will have to be worked out between you and your client, but that could be a challenge in and of itself. And of course, in some cases, you are specifying new products and technologies, and you as the designer will have to make an evaluation of what makes sense. And so if you're dealing with something that hasn't been done before, or is comparatively new, you want to request technical data. There's a lot of promotional material out there that promises a whole lot of different things. But you as the designer need to go beyond that. If possible, you want to evaluate comparable projects, ask the representative for both the good and bad results of the use of the product. And if possible, always notify the manufacturer in writing of the way you intend to employ the product, so that at least they're aware of what you intend to do and how it's being used. Research their reputation, financial condition, and production capacity, and keep your client fully informed of any risks associated with the use of the product discovered in your research. You need to think about, in terms of informed consent, making sure that the client, if there are any risks, is made aware of them and is assuming, or at least is aware of the risks and is assuming some of that as well. So that is really the end of my prepared remarks. I just want to thank you for attending. Look for the survey and your downloadable certificate. And in addition, I just want to bring your attention to the resources at our website. This is the homepage for our School of Risk Management. The far left is where you can find our contract review sifter. And you can also have access to our on-demand risk management courses. All of these are free for those firms that are part of our program. And their courses are accredited for continuing education credit by the AIA. And so a lot of these courses actually meet your state licensing requirements. Also be aware that we have a lot of resources available to you. And we also have our blog, which is available to you as well. So keep an eye out for developments in the industry that you might find useful. And with that, I thank you again for your attention. I hope you find this program useful, and please keep an eye out for the survey, fill that out, and provide us with the required information so that we can file this on your behalf for the AIA. Thank you very much.